Did you know that in 2017, scientists made a groundbreaking discovery unlike anything seen before in human history? For the very first time, they detected a mysterious object entering our solar system from interstellar space, far beyond the familiar orbits of planets, asteroids, and comets. They named this intriguing visitor Oumuamua, meaning scout or messenger in Hawaiian, perfectly capturing its enigmatic nature. Almost immediately, Oumuamua became the center of an intense scientific mystery, baffling astronomers and challenging our fundamental understanding of physics. Why? Because instead of following a predictable, stable path like other celestial bodies, this strange object seemed determined to break every known rule. Its peculiar trajectory defied explanation, triggering wild theories, from being a fragment of alien technology to simply an unexplored natural phenomenon. Researchers have fiercely debated its origin, each new observation deepening the intrigue. Today, I invite you to join me on an exciting journey to unravel the cosmic mystery surrounding Oumuamua's extraordinary orbit. What secrets lie behind its bizarre behavior? Is it an alien probe, or merely nature pushing the boundaries of our scientific imagination? Let's dive into this incredible cosmic enigma together and uncover what truly makes Oumuamua's orbit so uniquely perplexing. Oumuamua, unraveling the mystery of its strange orbit and shape. To clearly identify an interstellar object, one originating from outside our solar system, scientists rely on three key criteria: its orbit, velocity, and shape. An outstanding example demonstrating these criteria vividly is Oumuamua, first observed on October 19, 2017, by the Pan-STARRS 1 telescope located in Hawaii. Right from its initial discovery, Oumuamua immediately captured scientists' attention due to its extraordinary elongated and flattened shape, distinctly unlike any typical natural object known within our solar system. This peculiar appearance alone was enough to spark curiosity, but even more intriguing were the observations revealing its exceptionally high velocity. Typically, celestial bodies follow elliptical orbits around the sun. However, Oumuamua's trajectory defied this common expectation. Its path was unusual, almost linear, and intriguingly, the object displayed a mysterious acceleration as it moved away from the sun, behavior completely at odds with conventional astrophysics. To better understand the enigmatic nature of Oumuamua, scientists employed advanced optical telescopes and radar observations, meticulously tracking its movement through space. These detailed measurements aim to unravel clues about its composition and origin. But despite sophisticated analysis, Oumuamua continued to present more mysteries than answers. The anomalous increase in speed, absent any clear indication of typical propulsion mechanisms, such as comet-like outgassing, perplexed researchers. Usually, a celestial body accelerating away from the sun implies it releases material like gas or dust. Yet Oumuamua showed no visible signs of such activity. Moreover, its remarkably unusual shape further complicated matters. Most asteroids and comets are roughly spherical or slightly irregular, but Oumuamua appeared elongated, almost cigar-like, measuring approximately 10 times longer than its width, a shape scientists rarely encounter naturally. This raised intriguing possibilities about its internal structure, rotational dynamics, and potentially artificial origins, fueling significant debate within the astronomical community. Adding to the mystery, careful tracking confirmed that Oumuamua was tumbling chaotically through space rather than spinning smoothly, like typical celestial objects. This erratic rotation hinted at a possible violent past event or interaction. Yet no definitive explanation has emerged. Today, despite extensive study, key questions remain unanswered. Why does Oumuamua exhibit such bizarre orbital characteristics? What physical or cosmic forces caused its unexpected acceleration and peculiar shape? And perhaps most tantalizingly, could it possibly represent technology from an advanced extraterrestrial civilization? Or is it simply a natural object manifesting phenomena yet unknown? Clearly, the stage is set for further exploration. With these intriguing puzzles firmly established, the logical next step is to explore the major scientific hypotheses currently proposed to explain the strange orbit and characteristics of Oumuamua. Let's delve into these compelling theories together. Leading scientific theories explaining Oumuamua's bizarre trajectory. As Oumuamua began its journey out of the solar system, it exhibited a highly unusual and puzzling phenomenon. It accelerated unexpectedly, defying the well-established principles of physics. This anomalous behavior immediately raised a significant question within the scientific community. What could possibly explain such strange activity? One provocative explanation, put forward by Dr. Avi Loeb from Harvard University, suggests that Oumuamua might be an artificial solar sail, an object deliberately crafted by an advanced extraterrestrial civilization. According to this controversial theory, sunlight exerted a subtle but continuous pressure on the object's large, thin surface, resulting in the unexpected acceleration observed as it moved away from the sun. Although fascinating, Loeb's hypothesis quickly faced intense skepticism and critical responses from other scientists, many arguing it relied too heavily on speculative and unprecedented assumptions. In contrast, a competing theory proposed by Dr. Alan Fitzsimmons of Queen's University Belfast offers a more conventional scientific explanation. Fitzsimmons theorized that Oumuamua is essentially a comet-like icy asteroid. As it approached the sun, internal ice beneath its surface sublimated, transitioning directly from solid to gas, and this process produced a faint yet sufficient thrust, altering its trajectory and causing acceleration. On the surface, this explanation seems straightforward and aligns more closely with known natural phenomena. However, it too has been met with skepticism, primarily because astronomers failed to detect any visible signs of gas or dust emissions typically associated with sublimation-driven acceleration. The scientific debate remains intense, with each camp presenting persuasive arguments and counter-arguments. Loeb's advocates highlight the unprecedented shape and motion of Oumuamua as possible indicators of artificial construction, while proponents of Fitzsimmons' theory emphasize simpler, natural processes, despite the lack of observed cometary activity. This deadlock illustrates how deeply Oumuamua challenges current scientific paradigms, pushing researchers toward reconsidering fundamental assumptions about interstellar objects. Yet, intriguingly, a new hypothesis has recently emerged, offering a potential synthesis between these two starkly different explanations. Perhaps, scientists suggest we are witnessing a previously unknown scientific phenomenon, one that incorporates elements of both artificial and natural processes, or perhaps reveals entirely new physics yet to be understood. With these unresolved mysteries, the stage is now set for deeper exploration. The next logical step involves carefully examining the observational measurements and scientific data collected, confirming precisely how Oumuamua moved so anomalously through space. Could new insights from these detailed analyses finally unlock the truth behind this cosmic enigma? Let's delve into that data and find out. Observational evidence confirming Oumuamua's anomalous movement. As we've just explored, theories explaining the strange motion of Oumuamua range widely. However, the crucial question remains. Is there solid evidence supporting any of these explanations? To answer this, let's delve deeper into the precise measurements and actual data collected by astronomers. From the very first observations, astronomers noted something particularly unusual. Oumuamua accelerated as it moved away from the sun, a behavior inconsistent with the natural orbital patterns expected of typical celestial objects. Why is this acceleration so notable? Simply put, an object typically increases its velocity only if there's an external force acting upon it, or some internal phenomenon occurring. For instance, when observing comets, astronomers frequently see visible gas and dust expelled from their surfaces, creating a jet-like thrust that slightly propels them forward. On the other hand, with Oumuamua, even the most powerful telescopes detected no trace of gas or dust emissions. This absence is puzzling, as it leaves unanswered the crucial question: what then caused this unexplained acceleration? To clarify the anomaly, researchers extensively utilized powerful space telescopes such as Hubble and Spitzer. These instruments meticulously searched for any subtle emission of materials, gases, or dust particles that might explain the mysterious behavior. Surprisingly, despite repeated observations and rigorous analyses, astronomers found no evidence supporting conventional outgassing scenarios. The data clearly indicated Oumuamua's unusual acceleration, but stubbornly refused to reveal its underlying cause. Additionally, precise measurements revealed another layer of intrigue. The object's acceleration rate didn't align with standard gravitational influences or simple solar radiation pressure alone, as would be expected from an asteroid or comet. Instead, this peculiar acceleration was subtle yet distinctly measurable, leaving astronomers to confront the unsettling possibility that existing physical models might not fully explain this interstellar visitor's behavior. The comprehensive dataset, accumulated by space-based observations, significantly elevated the scientific value of Oumuamua. It set an unprecedented benchmark in our understanding of interstellar phenomena, highlighting crucial gaps in current astrophysical models. Indeed, these findings have sparked widespread interest and laid the groundwork for future interstellar missions, which may soon target and study objects similar to Oumuamua to unlock their secrets. In conclusion, although the mystery of Oumuamua's strange motion remains unsolved, the wealth of data gathered from this encounter undoubtedly provides a cornerstone for future research. These observations ensure that the scientific community will continue probing deeper into this cosmic puzzle, determined to understand the elusive nature of interstellar visitors. Now, armed with this detailed understanding, we can shift our focus to another equally intriguing feature of Oumuamua: its chaotic rotation. Unlike stable celestial objects, Oumuamua tumbles unpredictably through space, further complicating our efforts to classify its true nature. Let's explore this remarkable aspect next. Chaotic rotation: why Oumuamua's behavior defies natural expectations. Imagine observing an object roughly 800 meters long, tumbling chaotically through space, spinning and twisting unpredictably, much like a gigantic bottle somersaulting endlessly through the cosmos. This vivid scene perfectly describes Oumuamua's bizarre state of rotation when scientists first discovered it. Dr. Karen Meach from the University of Hawaii vividly recalls how her research team struggled to believe their eyes as data poured in from the telescopes. The unexpected and erratic motion raised immediate questions. What could possibly cause such a large interstellar visitor to spin so uncontrollably? And importantly, could this chaotic rotation hint that Oumuamua isn't entirely natural? Numerous hypotheses quickly emerged. Among the most intriguing and somewhat humorous ideas was the possibility of a past collision. Could Oumuamua's chaotic rotation have resulted from an earlier cosmic crash, violently destabilizing its motion? Alternatively, are we perhaps observing an entirely new category of celestial objects previously unknown to science? To gain deeper insights, scientists compared observational data from Oumuamua to findings from known space missions, such as Rosetta's detailed examination of Comet 67P. Through meticulous analysis, researchers concluded that Oumuamua's rotation pattern starkly contrasts with natural objects previously studied. Traditional celestial bodies, including asteroids and comets, typically exhibit predictable rotations shaped by stable gravitational forces or symmetrical mass distributions. In stark contrast, Oumuamua's chaotic tumbling defies such common expectations, suggesting unique internal or external influences. Further adding to the intrigue, analyses showed that Oumuamua's rotation rate isn't uniform. Observations revealed that the object's spin fluctuates irregularly, indicating it may be influenced by asymmetrical mass distribution or internal stresses unseen in typical natural objects. This puzzling behavior further strengthens arguments for unconventional origins, perhaps indicating an internal composition significantly different from any previously studied celestial bodies. Despite extensive research, definitive answers remain elusive. While some argue this unusual rotation indicates artificial origins, others believe it simply underscores how little we truly understand about interstellar phenomena. Each theory prompts further speculation and inspires exciting new avenues for research. Personally, I find that although the exact explanation remains uncertain, one fact is clear: Oumuamua has opened a compelling array of intriguing questions. It challenges our established scientific frameworks, urging continued exploration and deeper investigation into the vast unknowns of our universe. Now, as we appreciate this ongoing mystery, let's step back to examine the broader implications of Oumuamua's discovery. Indeed, this interstellar visitor might serve as a catalyst, igniting new debates and discoveries about the universe's endless mysteries. Let's explore further how Oumuamua has already begun reshaping our understanding of the cosmos. Oumuamua's legacy, unlocking new cosmic mysteries. From the intriguing possibility that Oumuamua might be advanced alien technology, to the idea that it could represent a previously unknown type of natural object, one thing is abundantly clear. The universe still harbors countless mysteries, eagerly awaiting our exploration and understanding. Yet, we must humbly recognize that our current knowledge of interstellar objects like Oumuamua remains surprisingly limited. Leading scientist, Dr. Avi Loeb aptly summarized the significance of this discovery when he declared that Oumuamua has opened an entirely new chapter in astronomy. His statement underscores the profound impact and seriousness with which the scientific community views this enigmatic visitor. This realization naturally leads us to an intriguing and open-ended question. Are we truly prepared for the groundbreaking discoveries that future interstellar objects may bring? Upcoming missions, such as the European Space Agency's Comet Interceptor, scheduled for launch in 2029, illustrate our growing readiness and determination to seize such opportunities. The primary mission of Comet Interceptor will be to study and analyze interstellar objects similar to Oumuamua, as soon as they appear. Scientists eagerly anticipate that the fresh data gathered will provide critical insights, potentially unlocking some of the lingering mysteries left behind by Oumuamua. However, it is important to acknowledge that every ambitious space mission comes with inherent risks and technological constraints. Current limitations in propulsion, communication, and observational capabilities pose significant challenges. Nevertheless, it is precisely this delicate balance between potential breakthroughs and formidable obstacles that makes the journey into space exploration remarkably thrilling and deeply inspiring. Despite these challenges, optimism remains strong within the scientific community. The advancements made in recent decades, from improved telescopic technologies to innovative spacecraft designs, highlight humanity's remarkable capacity to overcome barriers and continually expand the frontiers of knowledge. Each new observation, mission, and discovery adds critical pieces to the cosmic puzzle, pushing us closer to comprehending the complexities of our universe. Looking ahead with confidence, it's clear that our quest for knowledge will persist with even greater vigor and dedication. Indeed, Oumuamua should be seen not merely as an isolated event, but as a catalyst, a powerful spark igniting a series of spectacular discoveries to come. Its brief passage through our solar system serves as a reminder of how much remains unknown, simultaneously inspiring scientists and enthusiasts worldwide to continue exploring and seeking answers. In conclusion, the journey of discovery never truly ends. Undoubtedly, Oumuamua represents just the first spark in an exciting series of extraordinary cosmic revelations awaiting us. The future is rich with promise, and the next great interstellar mystery is likely already on its way, awaiting our readiness to unravel its secrets. Together, we've explored the fascinating mysteries surrounding Oumuamua. From its peculiar trajectory and diverse scientific theories to detailed observational data and promising future missions, it's clear that while today's technology is sufficiently advanced to tackle such ambitious interstellar projects, executing them requires substantial economic investment and technical resources. Realistically, achieving success in future interstellar missions demands international collaboration, significant scientific resources, and millions of dollars in funding. Yet, objectively, we must acknowledge that uncertainty will always accompany our cosmic explorations. However, it's precisely this uncertainty, full of opportunities and challenges, that makes space exploration profoundly captivating and scientifically valuable. Exploration expands our understanding, ignites our curiosity, and creates lasting impacts. Thank you sincerely for joining us on this extraordinary journey. Your ongoing support and enthusiasm inspire us immensely and motivate us to continue producing compelling and enriching content. Remember to subscribe to the channel, share this video if you enjoyed it, and please comment below with topics you'd love us to cover next. Until then, see you in our next exciting discovery.